Okay, so now we're ready to use first principles to find some derivatives. Let's start with f of x equals x squared. So when we use the formula, we need to find f of x plus h. So what I would recommend is at the side, right, f of x equals x squared and f of x plus h. Using your functions from higher, you should know that's x plus h all squared. Let's now substitute in. So I'll keep the limit as h tends to 0, only deal with that at the end. So what do we have instead of this? We have x plus h all squared. And then we have take x squared all over h. The next step is to expand this so that we can try to simplify it. So you get x squared plus 2xh plus h squared take x squared. And what do you notice? If I can get it to work, the x squareds actually cancel out. That leaves you with 2xh plus h squared over h. You don't necessarily have to write that again because you can actually see it up there, but I'm just showing you how this works. And then you can pull out the common factor of h, so you can see h cancels down, which then leaves you with 2x plus h. At this point, I look at the limits when I've simplified it as much as I can and what happens to it as h tends towards 0. As h tends towards 0, this will tend to 0, which leaves you with 2x. And that means you have a derivative that f dashed x equals 2x. Quick check, you had x squared to begin with, equals 2x. So that's right, you've done right. The next one is f of x equals 5x. If you want to have a go yourself and just pause this, then you can do so. Just to remind you, at the side put f of x and f of x plus h, so try to find that. If you want to try it yourself now, pause. Otherwise, I'm about to go over it. Okay, 1, 2, 3. Right, so if it's 5x, f of x plus h means it's 5 bracket x plus h. You can expand that before you substitute in. I'm going to show you falling in here. So you have to substitute into the formula. So we get 5 bracket x plus h. So naturally we're going to open the bracket up. And what you can see is the 5x and the minus 5x cancel down. That leaves you with 5h over h, and you can see that the h's will cancel down and you're left with 5. So what does that mean? There is no h there, so there's no h to set towards 0. In fact, there is your answer. So you simply have f dashed x equals 5. Let's think about this, a quick check. If you had 5x, it would go to 5, so it's right. Let's go a bit tougher now. So what if you had 4x cubed? If you do want to try this one yourself, then I'm going to suggest that you expand x cubed or x plus h cubed and then find 4x plus h cubed first. Okay, so over the next 2 slides, I'm just going to remind you, you need to find f of x plus h, and then I would suggest that you find the f of x plus h all expanded before you go and substitute into the rule. If you want to try it now yourself and pause. Otherwise, I'm going to go through the steps of expanding this. Okay, so x plus h cubed would be x plus h times x plus h squared. You know the squared is x squared plus 2xh plus h squared times everything by x times everything by h. And then collect together, you've only got x cubed, but you've got x squared h and you've got an x squared h here. So collect together. And then lastly times everything by 4. It's really involved, so I would recommend doing that at the side before you even start proving the first principles. If you want to try it from this stage yourself, then pause and try putting it into the formula now. Okay, so now I'm going to put it into the formula. Right, what do we have? We know that f of x is that, and we know the f of x plus h. Let's substitute into the original formula. So we have 4x plus h cubed minus 4x cubed, but we've already expanded it above there, haven't we? So I'm going to put that in, and right away you'll see 4x cubed cancels with the 4x cubed, leaving you with the 12x squared h, the 12xh, and the 4h cubed. You can instantly see that h cancels down, so you can take h to the power of 1 off of everything. And what I've done here is put them in a different colour to remind you this is going to tend to 0 and this is going to tend to 0, which means you'll be left with 12x squared. You're left with 12x squared. That is in fact your derivative. Let's do a quick check again. Yes, That absolutely works. Are you ready for a superhero one now? Okay, what if it's got a root in it? If it's got a root, then what you have to do is think about a difference of two squares. It's not that you're going to rationalise a denominator or anything, but as soon as you see a root and you will have two different parts with roots in it, then you'll have to try and simplify the problem. So the hint is the difference of two squares. I wouldn't try to do this one yet myself. I'll try one later on, but it's your call, okay? Right, so how would I cope with this? The f of x plus h is 3 root x plus h, which is obviously quite tricky to do. So when we substitute in here, we've got 3 root x plus h minus 3 root x over h. And if you remember, I said we're going to have a difference of two squares. If that is take, we will have plus. Okay? You might not think that looks easy at all, but believe me, it's going to simplify really nicely because 3 times 3 is 9, and root x plus h times root x plus h is just x plus h. Minus, and the plus cancel the middle terms out, which is why we're doing this, and then plus and minus is minus. 3 3s are 9, root x times root x is x, so it goes actually really nicely to that. The next stage is to open up the brackets as we have done before, and then you'll see that 9x and then minus 9x cancel out. And you'll notice that throughout this, I have never attempted to open up that bracket. The h has just stayed at the front, and now you'll see why, because the h's will cancel down really nicely there, and we're left with this. Now, normally I would have the h here, but I'm just emphasising that, remember, as the limit of h tends to 0, this part here is going to tend to 0. So it means that you end up with 3 root x plus 3 root x there, which is in fact 6 lots of root x. And then we can divide by 3 and get 3 over 2 root x. We could write it in this form as well. I'm pretty happy with it in that form, but for you to make a connection with this derivative here, that will be 3x to the half. Then a quick check, that works, okay? So this is the method, the trick here, okay? Right, what about trig? Trig is far more involved and really pretty involved. So you need a calculator for this. So what I want you to do is make sure you've got a calculator and put it in radian mode. Before using first principles with more complex functions like sine, cos, even exponentials, we need to explore what happens as you look at the function tending towards 0. So make sure your calculator is in radian mode. If you put these into your calculator, you'll find sine 0.001 in radians. Have a look at what you've got. Now do the same for cos. Now I've not put any of the answers here. I'm just getting you to explode in the calculator while I babble on. You remember that cos 0 goes to 1, so all of those ones should go to 1. You should find that this tends towards 0, okay? But the whole point is checking you've got it in radian mode. Why am I doing this? So you're going to find trig derivatives easier if you consider two special calculations. These aren't the calculations just yet, but I'm just making sure that you are getting similar answers out to me, that this one is almost at 0 and this one's almost at 1. So we need to find out what these two special calculations are now. Okay, so what if I said to you put 0.001 in, then sine h over h? You might think, why is she doing this? But you'll see it up here soon, so it's important that you know what this is. If you don't know what it is off by heart, that's fine. You can use a calculator and substitute, and there's no hassle with that. So I'm putting the 0.001 in here just now. Remember, when you put that in the calculator, that it'll open up a bracket. So remember to close the bracket before dividing by that. And then when you put it in, you end up with 0.99999. So that means that this calculation, as you put in numbers that are tending towards 0, means that as h tends to 0, this tends to 1. Over here, if you put in 0.001 for this one here, then you'll end up with, remember, close the bracket, of course, before you take the 1. And then remember to get that answer before dividing or have the whole numerator in the bracket. Then what you'll find is this gets closer and closer to cos 0, so this gets closer and closer to 1. So effectively what you end up with is pretty much 1 take 1 at the top so it goes to 0. So that means that this part here, this calculation, goes to 0. Okay, they will become evident when I start the first principles for it. So the next thing is, eventually you're going to try a question that might have a multiple in it. So let's just make sure you're happy again. If you put 0.001 in, then you'll get that. And if you put it into your calculator, you'll find that sine 5h over h tends to 5. So you'll know what sine 4h over h, sine 3h over h, and so forth. Cos 5h over h minus 1 over h rather will tend to 0, because if cos 0.0001 tends to 1, cos 0.0005 will also tend to 1 as well. So you still get 0 out for that. Right, let's do it. Okay, so let's go for sine x. If you have f of x plus h, then you have sine x plus h. I've not put it to the side this time, I'm just going straight into it. But what I do have at the side is to remind you that that is in fact the addition formula. So you need to expand that. So you'll have sine cos, cos sine. And remember, it's sine, so it's still plus. This is in purple, not because they can cancel out this time, but it's because you can see there's a common factor of sine x. So what we're going to do next is pull out the common factor of sine x, and we will get that. So sine x has the cos h beside it, and then if you pull out sine x, you'll have minus 1. Very complicated looking, so what we're going to do is separate them into two separate parts. So we're going to have sine x with the bracket all over h as 1, and then have, and we'll put the limit here as well, cos x sine h over h. What you'll also notice is we're looking at as h tends towards 0, so we're only interested in the h part of it. So we're going to pull out the sine x and the cos x to the front. So that means the sine x comes out, but we still have all of that looking at as it's tending towards 0, and pull the cos x out as well. This is where those fancy calculations come in. So if you remember, we have just been looking at using radians and finding out these calculations, which means that this part here tends to 0, and this part here tends to 1. So we can then get to this here. 0 times anything 0, so the derivative is cos x, which of course you know. Okay, so what did we do? We substituted in normally with the x plus the h. We used the addition formula with the trig, so you have to know that off by heart. We then tried to pull out the sine x and cos x. Once we pulled out the common factors, then get the sine x and cos x to the front, and then use your special calculations. Okay. Okay, so it's time for you to try it out. So you try A to F over page and flip back whenever you need. So this is what you've got. You'll find that